There are so many different types of chemical reactions. As we start to learn how to predict them, it can be really helpful to first classify them into different categories. Now, as we classify the reactions, there's two main viewpoints that you can use to classify the reaction. So you can view the molecules and the ions from an atomic level. There's a number of types of reaction that fall under this atomic level classification system, and then there's a different classification system that relies on what you can actually see. So the atomic level system is useful because it tells you what the atoms and the ions are actually doing, and the macroscopic level is really useful because it tells you what you could actually see as you are observing a reaction. Now, these two don't necessarily correlate with each other, but it's important to be familiar with both. So let's start with the atomic level. On the atomic level, you will have combination reactions, single replacement reactions, double replacement reactions, and there's also decomposition reactions. Now, these atomic level are really useful because it tells you what the atoms are doing. So a combination is where you have two different types of elements and they combine into one single compound. A single replacement is where you have a single element and you have a compound. Now what happens is the single element switches places with either and you get a new element and a new compound. A double replacement is where you have two compounds and the cations switch place. And a decomposition reaction is where you have a compound and it breaks up. For this class, we will focus on the first three. Looking at a reaction from the atomic level is really helpful because it allows you to predict whether a reaction might occur or not. However, you can't see atoms, and so sometimes it's really helpful to classify a reaction based on what you actually see happening. Some different classifications for the macroscopic level are precipitation reactions, acid-base neutralization reactions, gas evolution reactions, and oxidation reduction reactions, which are also called redox reactions. Now these are based on what you will see during the reaction. So a precipitation reaction, you would actually see a solid starting to form. Now it might be a solid at the bottom of your beaker or something becomes cloudy. If it's becoming cloudy, then you've got small solid particles forming. A neutralization reaction, you could observe it by the change in the pH of the solution. Like if you started with one acid and one base, the pH of the acid would be very low, the pH of the base would be very high, the pH of your product would be near to neutral. A gas evolution reaction, this one you would observe by the presence of bubbles in your reaction, or sometimes by a smell. And an oxidation reduction reaction, these are really common and you can observe them in a bunch of different ways, and so we won't focus on the macroscopic observations that you would have from an oxidation reduction in this video, although we will talk about that later. Now the macroscopic ones, we will talk about all of these will be important in this course, and generally the precipitation, the neutralization, and the gas evolution, these all tend to be double replacement reactions, although they don't have to be. Often they are. And the oxidation reaction tends to be combination, single replacement, and decomposition. Although it doesn't have to be, it tends to be.